Now let us move to the next section in our course, that is channel names and terminology. The objective of this particular section would be understanding the relationship between LTE protocol layers, that is logical transport and physical channels, via logical transport and physical channels, and explain the logical and transport channel in depth used in this particular LTE, and name downlink and uplink physical channels and understand their purpose in LTE, and finally understanding the overall LTE channel structure and mapping for both the downlink and uplink. Finally, we'll see how many acronyms that we have came across and how much we can remember in this particular section. This diagram describes the overall structure of LTE air interface. It has, as we have seen before while we are discussing LTE air interface protocol structure, we have RRC, that is radio resource control, at the top, which is responsible for control channel or controlling the, which is responsible for in the its actions in the control channel, and we have application layer which is actually generating the data which is carried over by radio bears here. Then comes radio link control. It is actually responsible for controlling the link. Such main functionality such as flow control and error control or sending of ACNACs at RLC level is done by this particular layer. Medium access control is responsible for accessing of medium, that is air interface here, that is where to place our data in the frame or other things is the job of this medium access control. And finally, it is the physical layer through which we will be sending the actual physical data over the air interface. Let us see each layer and its functionality and the channels that are used in between the two layers in depth. Now, radio resource control is responsible for generation of signaling radio bearers and assigning them to the resources that are provided by the lower layers in the form of logical transport and physical channels. So, the signaling radio bearers that are generated by RRC is given to the RLC to perform to perform uh, actions of to perform RLC actions over it and place them in logical channels. So RLC functions include for flow control, error control, etc., and numbering of the frames and etc. is done in RLC, and individual ACNAC for each frame is done at RLC level. So each the frame here is not physical frame here. The whatever the RLC unit packet, uplink packet or downlink packet that are carried over these logical channels. And apart from the signaling radio bearers, logical channels also contains information that are present in radio bearers, which are generated by the application layer. These logical channels further give these logical channels to the MAC, and MAC perform the actions of MAC such as interfacing with the air, and finally placing the logical channel data that are present in the logical channels in a correct way how the air interface needs it in a, and it forms and it generates something called as transport channels. Finally, these transport channels are given to the physical layer, and it is the responsibility of the physical layer to generate the signals that are carried over the air interface so that it will reach the opposite end via the physical channels. One more thing to note in this particular slide is RRC can control all the three layers that are present in the access stratum. Those are RLC, MAC, and physical layers. So, apart from this layers, there are only few signals that are present in the physical layer. That is, RRC cannot control the information that is present in the physical signals. So they are present in the physical layer only. One example of these physical signals are synchronization signals. These synchronization signals are used for time and frequency synchronization when we are first going to communicate between inode B and UE.